Good afternoon, everyone. Hope you're having a great conference. I'd like to thank the team at QCT for giving us the opportunity to talk about AMD's server product line. We have a long-standing, deep partnership between AMD and QCT, and we are super excited about the product portfolio that we're bringing forward based on second-gen EPYC. Let me first begin by a quick walkthrough of AMD's server processor strategy. There are three pillars for our strategy. The first is to deliver high performance across a broad swath of workloads. When we think about setting our roadmap, our product or technology roadmap, we look across the various verticals and the kinds of applications our customers are deploying in today's data centers and out into the future, whether that's high-performance computing, whether that's cloud, whether that's enterprise, virtualization, AI analytics, or software-defined infrastructure. And there's one thing that comes across all of those workloads, and that's the insatiable need for high performance. And our foundational pillar for our strategy is to deliver that high performance. The second pillar for our strategy is to deliver leading-edge technologies. We want to collect industry-leading technologies, whether it's manufacturing process leadership, memory leadership, I/O, or security technologies. And our goal is to assemble those leading technologies into a product that pays off on performance for our customers. And third, we want to deliver that with a fully open ecosystem so that our customers have a ready-to-deploy solutions on day one based on our platforms. So when you put all of these together, industry-leading technologies delivering high performance along with an open ecosystem, that's how we deliver an improved total cost of ownership for our customers. When you implement this strategy, what we get is a roadmap that we are marching to. We have a very strong and long-term roadmap targeted for the data center. We know that our customers in the data center don't buy a point product. They look for a roadmap of consistent delivery, and that's our commitment for our customers and for the industry. We re-entered the data center market with our first-gen EPYC processor in 2017, and at that point, we laid out this roadmap, and we have been executing like clockwork to this. We have just launched our second-gen EPYC 7002 series last month. We are completed design for our third generation, codenamed Milan, and we are in design for our fourth generation, which is Genoa. So we are executing to deliver the roadmap that we've set in place more than 2 years ago. When you double-click onto the current product, the second-gen EPYC, it sets a new standard for the modern data center. And the reason we say that is because it's truly a transformational product. It is a product against which everything else in the data center is going to be measured by. It delivers leadership across the board. If you look at performance for EPYC 7002 series, it delivers an incredible 2x performance compared to our previous generation, and it delivers almost 2x performance compared to our competitors' leading-edge top-of-the-stack product. It delivers leadership architecture. We've introduced chiplet architecture with our first-generation EPYC processor, and we've taken that to the next level with a hybrid multi-die approach with second-gen EPYC, which really provides us configurability, scalability, and flexibility. And then it delivers leadership security. We have an embedded secure processor that is part of our core, and that helps us deliver a hardware-based root of trust. So if you look across the various elements that a data center would care about, performance, architecture, and security, we deliver leadership across that. The underpinning of our second-gen EPYC is the second-generation Infinity architecture. This is kind of the secret sauce that enables us to deliver the performance and the capabilities and the features in EPYC 7002 series processor. And there are 4 elements to that. The first is performance, and this is a thread that runs across all of our product roadmap. Going from Zen 1, which was the core in our first generation EPYC, to Zen 2, we've delivered more than 15% IPC improvements. We've delivered a second generation Infinity Fabric with our second gen EPYC that improves the bandwidth as well as reduces the latency. And this helps the communication within the chiplets as well as inter-socket communication. The second key element is our hybrid multi-die approach. We know that I/O doesn't scale as well as logic, so we picked the process technology that's best suited for the silicon that we are deploying with. So I/O in 14 nanometers to leverage the mature process node, and logic in 7 nanometers to deliver the best performance. We are focused on throughput with industry fastest memory bandwidth as well as I/O capabilities. And lastly, security is something that is built into the DNA for our design team. Implementing an architecture, there are lots and lots of trade-offs involved when you go from a microarchitecture to implementation. And we are very security conscious in the kinds of choices we make in those trade-offs. And as a result, we have security that's kind of built into the core. And the proof of that is there's a number of side channel attacks that we're actually immune to because of the design choices that we made. Now, when you have this architectural approach with these 4 elements and put that together into a product, you get EPYC 7002 series processors. So this is kind of the feature set on a slide. If you look at the top left, each EPYC 7002 series processor comes up to 64 Zen 2 cores. So we have a full product lineup. The top of the stack has 64 Zen 2 cores. That's 2x compared to our first gen EPYC. If you look at the third level cache, the L3 cache for each of these, around these, we have quadrupled that going from gen to gen. So on a per core basis, we've doubled that. And at the overall chip, it is 256 megabytes of cache. With a hybrid multi-die approach, we have flattened out the NUMA domains so for more consistent memory latency. And we have a full range of products ranging from 120 to 280 watts in terms of TDP. When you look at memory, we have industry-leading 8 memory channels with 3,200 megatransfers per second. This delivers the fastest memory performance on the planet in a server processor. And we have a full spectrum of DIMM types that we are validated along with our processor, and we can deliver up to 4 terabytes of memory capacity, all with full RAS capability with ECC protection. When you look at the top right in terms of performance, we're delivering 4x this floating point performance going from gen to gen. In each of these cores, we've doubled the data width from 128 bits to 256 bits, and we've doubled the number of cores. So it's 2x times 2x, 4x the performance on floating point, and we've doubled the integer performance. And this is an incredible leap from going from generation to generation that we are bringing to the table with second gen EPYC. When you look at I/O, we don't have a separate south bridge, so this is integrated into the processor, and we're delivering 128 lanes of PCIe Gen 4. This is an incredible I/O capacity as well as incredible I/O bandwidth. So with PCIe Gen 4, you go from 8 gigabits per second to 16 gigabits per second, so double the bandwidth. And we have, with the kind of lane count that we have, you can attach a number of devices with no PCIe switchers or no latency and get overall system throughput and system performance. And when you look at security, I talked about our embedded secure processor that delivers the secure root of trust, but we also have instructions that we've built into the CPU that deliver secure memory encryption. So you can encrypt all of the memory with just a BIOS switch with no changes to the application. And we have secure encrypted virtualization where you can have cryptographic protection of your data in a virtual machine from other virtual machines as well as the cloud hoster, the hypervisor. Now, when you pull back a little bit and sum it all up for EPYC, it has more cores and faster cores. It has more memory and faster memory. And it has more I/O and faster I/O. And it has security that's built into the core. So what that means is It's the industry's first 7-nanometer x86 server processor that delivers the highest performance with industry-leading memory as well as I/O technologies and security. And all of that delivers tremendous TCO for our customers. When you look at performance, I wanted to double-click a little bit more. We are delivering phenomenal performance across the board with second-gen EPYC. 97% better performance when you look at SpecInt compared to Intel's Cascade Lake 8280. 88% better performance when you look at SpecFP. 84% better performance when you look at SpecJBB. And these are just benchmarks. When you expand that out to workloads across the verticals, we are head and shoulders above performance compared to the best that our competition is able to offer. We have about 47 different benchmarks, world record benchmarks in STI and enterprise, 30 different world records in big data, 18 world records in HPC, and on and on. So when you look across the kinds of workloads that are deployed in the data center, EPYC delivers phenomenal performance, not just a small performance increment, but epic performance increment compared to our previous generation as well as our competition. When you deploy EPYC in a 2-socket configuration, you get the ultimate performance. You get more than twice the core density. You get industry-leading memory bandwidth, 45% more memory bandwidth compared to the top of the stack from our competition. An incredible amount of cache, 512 megabytes of L3 cache and 64 megabytes of L2 cache. So more than half a gig of cache. That's an astonishing number to look at. And then incredible I/O capability, both capacity as well as bandwidth. And in a single socket setting, we deliver a killer TCO. This is a complete game changer. EPYC 7002 series single socket delivers the features and the performance of 2 sockets in 1 socket. So when you look at our single socket, you get all of the enterprise class features, you have great core density, and you have all of the memory and I/O capability, but in a single socket setting. When you look at it in a deployment scenario, it gives you 62% better power efficiency compared to what Intel's able to offer. And when you look at that, you're able to pack more in a given rack. So from a compute density point of view for a given footprint, you're able to get a tremendous amount of compute out of a given footprint, and that translates to overall TCO savings. So for one 7702 64-core processor, more than outperforms 2 8276. This is almost the tippy top of Cascade Lake stack. And that's an incredible comparison to look at. So one CPU replaces 2 high-end Intel Platinum Cascade Lake CPUs, driving that almost half the TCO. And then on top of that, if you layer in software costs, like VMware software that's licensed by socket, you're able to support more users with half the license cost with a single socket than what you're able to with 2 socket licenses and the cores that are associated in a 2-socket Intel platform. Now, I talked about our hybrid multi-die approach. It really provides us configurability and flexibility as we think about setting up our product stack. And we layer in a customer-centric approach to that when we design our product lineup. And that means a focus on 2 things. The first is simplicity. We want to have a clean, simple product stack when you think about speeds and feeds, as well as features. But second, we want to provide a choice to our customers that is true choice without really driving them to higher up the stack artificially in order to buy a certain feature set. So when you look at our product lineup, all of the features are available across the board. So the industry-leading memory speed available across the product stack. Industry-leading I/O capacity and bandwidth available across the product stack. The security features available across the product stack. So with that philosophy, we're able to let our customers choose the core count and the performance point that works for them without pushing them artificially up the stack just to buy a higher priced part. Now, one of the keys when we look at performance, the IT decision makers really look at performance per dollar. So what am I getting for a given dollar that I'm spending. So in this chart, we have performance on the y-axis and the various clusters of comparisons. When you look at the comparison of our second-gen EPYC processor with the Intel's silver, gold, and platinum lineup. And when you look at the left-hand side of the chart, comparing to 4215, the silver class processors, our 8-core processors provide 2x the performance per dollar. So 50% more performance at lower price. That translates to 2x the performance per dollar. When you look at Intel's gold lineup, the 6000 series, compared to our 24-core, we deliver more than 2x performance per dollar. When you look at higher up the stack, with our 32-core processor, we again deliver 2x the performance per dollar, and almost 2x when you compare the Platinum 8000 series to our 48-core processor. And when you look at the top end, we are delivering twice the performance at half the cost. That's a 4x performance per dollar improvement when you look a head-to-head comparison between our 64-core and Intel's top of the stack 8280. And this is an astonishing chart when you're an IT decision maker. If you have a given IT spend, what this means is with second-gen EPYC, you're able to do more. You're able to support more users, scale more broadly, or deploy more services. On the other hand, if you're trying to get to a certain performance metric, if you want to create a cluster that lets you support 10,000 new users, you're able to do that with less servers with AMD EPYC second gen compared to a corresponding Intel system. Either way, you win. That's how the performance kind of pays off for our customers. Now, when you pull it all together from a processor point of view, we are providing an incredible offering with a second-gen EPYC, but we're doing a lot more around the platform to create an ecosystem that our customers can use to deploy solutions on day one. So we, of course, work closely with partners like QCT on the platforms, but we also work with a number of hardware vendors around memory, storage, as well as accelerators. We have great support for operating systems and system software in day one for Windows, Linux, and virtualization with VMware and Citrix. And we have a very broad swath of application stack looking at databases, either SQL or NoSQL, or data analytics, cloud-native frameworks like containers. All of those are optimized on day one and available in a solution portfolio that our customers can take advantage of right off the bat from the get-go. When you look at the impact of what second-gen EPYC processor brings to the table, it's delivering more than 2x the performance, both compared to our previous generation as well as the competition. It's delivering more than 2x the performance per dollar, so at every price point, you're getting twice the performance. And that translates to more than half of the TCO when our customers deploy their workloads and their solutions. So when you put it all together, second-gen EPYC is the world's first 7-nanometer x86 server processor that delivers the highest performance along with leadership feature sets and security that's built into the core. And what that translates to is our customers can do better, faster, cheaper with second-gen EPYC. And that truly is an epic achievement. Thank you.